right? So that's something to be mindful of, right? But once you do that, we multiply through with our LCD. So whatever this denominator is, I call it the LCD. I'm going to multiply it by that. Use a little shorthand notation. So 7x squared plus 5x plus 23 is going to be equal to a times x squared plus 4 plus bx plus c multiplied by x plus 1. All right. The way we kind of addressed this last class, just to streamline the process and not have to show every little minor algebraic detail, was to say, if I'm multiplying by this set of factors, I'm multiplying it by this fraction, the only thing that's going to be left over is whatever is not in this denominator. Right? So I already have an x plus 1. That's going to cancel with the x plus 1. So that'll give me a factor in the numerator of x squared plus 4. Here we have the x squared plus 4, so that'll cancel, leaving me only with the x plus 1. Once you get to that step, it's a matter of using your distributive property, ax squared plus 4a plus a little foiling on this one. You know, not ideal, but we'll live with it. All right. So we're going to take anything that has an x squared associated with it, put it together. Now again, last time what we did was we said, all right, 7x squared equals ax squared plus bx squared, and then we canceled the x squareds. So let's just cancel those on the fly and just say 7 is equal to a plus b. For the x's, I have 2 of those, so I have 5 being equal to b plus c, because the x's are going to cancel out. And then 23 is going to be equal to 4a plus c. Now, you may not have seen the need to use the matrix approach last time, because the algebra wasn't bad. And it's still not terrible. It's just, I don't want to do it. I've done enough algebra. I passed that class. I don't want to do it anymore. Where possible, you know? So, I'm going to use the matrix now. And besides, it's going to gear me up for Calc and linear algebra, so. A plus B. I'll leave a little gap here, because there's a 0C, a little subtle reminder to myself. B plus C is equal to 5. 4A plus C is equal to 23. You can go right to the matrix, though, if you want, if you're comfortable with that. If you're not, that's understandable, too. Coefficients 1, 1, 0, 7, 0, 1, 1, 5, 4, 0, 1, 23. So then we go to the calculator. Shocking. Movie reference? Shocking. Also, that's 0. Now, it could be, but there was one I was thinking of in particular. Now you got to get into like the mind reading stuff. It was a Mel Brooks movie. So, just a refresher to get into the matrix. I hit second inverse key. I go to edit. Three by 4 is what I have from last class, and it's what I need now, so that's good. 1, 1, 0. Oh, we didn't do this problem already, did we? Oh no. Good. 1, 1, 0, 7. 0, 1, 23. All right. Get your matrix in. Quit out of there. Matrix menu, so second inverse key. Go to math. Select reduced row echelon form, RF. Select matrix A again. You have to go into the matrix menu to get it. So second inverse. Select option A. Hit enter, and it'll do all the row reductions that you need in order to get your solution. So it's doing the heavy lifting for you. So that's telling us that A is equal to 5, B is equal to 2, and C is equal to 3. Right? So now I know what my new integral ought to be. 5 over x plus 1 plus, we have a 2x plus 3 over x squared plus 4. So this one's a little bit crazier because now that we have it in a more convenient form, it's good. We got a lot of good stuff done, but there's still more work to do. Because the first part is something I can anti-differentiate right now. The second part requires a little bit more time and effort. All right. So we can anti-differentiate this right away. Call that 5 ln x plus 1. The other part, I'll write it as plus antiderivative 2x plus 3 over x squared plus 4 dx. All right, so we have to address that now. And hopefully, I mean, you may disagree, but hopefully that kind of justifies learning this, because this is just extra work that you didn't have to do because you have to worry about this, so why do you even want to worry about that other stuff? You know? So, ooh, that was crazy. I don't even remember putting that on there. So, let's tackle this guy. I see a plus sign. Plus signs are good in the numerator. We like those. 2x over x squared plus 4 plus 3 over x squared plus 4 dx. Experience is the best teacher in a lot of ways. What I've been saying all along, I think, is that if the numerator is the derivative of the denominator, then you have your antiderivative. It's a natural law. Look at your denominator. Look at your numerator. If I take the derivative of this, will I get that? Yes, I will. So that means that that part, at least, is just the natural log of x squared plus 4. The other part, a little bit of a different story. All right. So there are shortcut rules when it comes to problems that almost are inverse trig rules, but not quite. And you're welcome to put these rules down on your note card if you want. You'd have to research them, but they're there for you. I would look at this as a trig substitution, right? So whether you like it or not, that's the way I would do it. And so, because again, I'm not like, rules are good, but I don't like to use them as a crutch. And so, in this case, what I would do is draw the triangle, label it. I'm going to have my U and my A. U is X, A is 2. Place them appropriately. All right. So, and we did the little nifty trick last class of, yeah, there's not a radical in the bottom, so what do? We write a radical in squared, but we can do that on the fly in a second. So I'm going to put an X here and a 2 there, and make this x squared plus 2, x squared plus 4 under the radical. All right, and we'll address that in a second. So variable, let me go different color. Variable to constant, opposite over adjacent, tangent of theta is equal to x over 2. Radical over constant is hypotenuse over adjacent. So secant. This one I'd clean up to write x equals 2 tangent theta. Dx would then be equal to 2 secant squared theta d theta. The other one we just have to clean up a smidge, the teensy tiniest bit of cleaning up, and that would be radical x squared plus 4 equals 2 secant theta, sorry. And you can say, well, but there's still no radical in the original problem. That's going to be handled in a sec. So take this guy here. That's going to be the result of this. 3 over, if I just put the 2 secant theta in, that's the same as saying radical x squared plus 4. But I want just an x squared plus 4, so I'm going to square this. The dx is just 2 secant squared theta d theta. And we get some good cancellations, like really good cancellations. It ends up being, well, the 2 goes into 4 twice, so 3/2 d theta, which is 3 over 2 theta. Okay, so it's a little funkier, but still doable. And again, there is a shortcut rule to this, but that's for you to figure out on your, or not figure out, but research on your own, because there are people that just build their websites based around shortcut rules for calculus and YouTube channels and things like that. So you could find what you need there. All right, so to go back to what I was looking for originally, I would take my tangent function, this guy here, tangent theta is equal to x over 2. Find the inverse of both sides, and you get theta is equal to the arc tan of x over 2. All right, so we got all these scattered bits and pieces here of this glorious problem. 5 natural log of x plus 1, way back from the beginning. Plus the natural log of x squared plus 4 plus 3 over 2 times the arc tan of x over 2 plus c. That's what our antiderivative would be.